Welcome to EDU World Space.
So in this question, we are required to estimate the increase in volume of pressure in problem 10.56, right? So let's start with the solution. The solution is very simple. So in problem 10.56, right, we found that for this problem, the increase in the radius and the length were del r, change in r was 1.6 into 10 raised to power negative 3 meter, and the change in the length was 2.25 into 10 raised to power negative 3 meter, right? So imagine that the old cylinder being a smaller cylinder, right? Let me write it down. So imagine that the old cylinder being a smaller cylinder, right? Smaller cylinder. So smaller cylinder inside the new one, right? Inside the new one, right? So what I'm trying to say over here is that you need to imagine that the old cylinder is inside um it's inside the new cylinder, right? And it's small, right? You need to imagine that the old cylinder is the smaller one and inside a new big cylinder. Fine. So now there would be some difference in the volume between them, right? So there would be some difference in volume between these two cylinders, right? So only that is how it's possible that this old cylinder is smaller and it's inside the new cylinder, right? So that difference is what we want to find, right? That difference is a thing that we need to find out, right? So now for the volume to increase, right, there will be two ways. One would be because the radius change, right? And the other one would be that the length somehow change, right? Only by these two changes, or like if the radius will change, then the volume will change, right? And if the length would change, then again the volume would change. So um because the radius changes, the change the volume, right? So let's study them separately. First of all, we'll deal with the change in the radius, right? So if the radius changes, right, the change in volume would be change in volume would be it would be del v sub r is equal to pi r plus del r whole square negative r square, square bracket closes, l, right? And then, right, so this is the change for the change in the volume, right, if the radius increases. Now let's study the change in the volume due to the change in length, right? So if length changes, the change in volume would be, so let's take a look at that. So we have the change in volume due to length, and it's equal to pi change in radius plus change in the radius square times change in length. Right? So from this equation, we can say that if the length changes, the increase of the volume will be somehow um, like this because the radius would have already been changed, right? So the complete change in the volume of the cylinder would be the change in volume would be del V, that is equal to change in volume due to radius and change in volume due to length, and this would be pi square bracket r plus change in radius square negative the square of the radius times length, plus we have pi the change in radius plus the radius whole square and change in length. Right, now we have all of these um, variables values, right? So just plug them in and we'll get our answer. So we have pi point 0.5 plus 3.2 into 10 raised to power negative 3 square negative zero point 0.5 square bracket closes plus, since I'm running out of space over here, so it's better that I write in the next line, plus pi into 3.2 into 10 raised to power negative 3 plus zero point 0.5 whole square into 2.25 into 10 raised to power negative 3, and that is equal to, when you calculate it, so that would be equal to 0.0168 meter cube, right? So this is the complete change in the volume, right? What we simply did is that we assumed or we imagined that the old cylinder is a smaller cylinder, or you can say it's a small cylinder, and it fits inside the larger new cylinder, right? And the difference, and from this assumption, we assume that there would be some difference in the volume of these two cylinders, and this difference in the volume of these two cylinders were the thing that we were required to find out, right? And now the volume of the cylinder, it can change due to the change in the radius or the change in length, right? And then we studied them separately, right? That what would be the change in the volume due to the change in the radius, and we got an equation for that. And then we started that if the length changes, what would be the change in the volume, and then we again got a new equation, and then we added them, then just plug in the values, and we got our um, answer, right? So this is your solution, and it includes our answer for this question.